Thank you. So I want to talk about effective software development, and I looked up what effective meant, and it said, well, successfully producing a desired outcome. And I think it's about business value, and sometimes it's easy as a developer to lose the fact that the business value is the important thing, especially when you get into yak shaving. So you find yourself doing some task that is many steps removed from what you actually wanted to achieve, but there's a logical set of steps that have taken you there because you wanted to make a small change to some functionality, and then you discovered that the acceptance tests had been written in a way that meant you had to change every single fixture to add this new field, and then you go to deploy it and you discover that you don't know how to do this deployment because a different kind of build and deployment pipeline that you haven't used before. So basically you find yourself shaving a yak thinking, why am I doing this? And I've worked for the last 4 years, well, probably longer actually, 4 or 5 years doing things like platform building and engineering enablement, which are all about trying to remove those steps so that you can just produce business value. So developers can just do something that is useful. I think this has been mentioned in the majority of talks I've been in so far. If you haven't read it, it is really worth reading. I'm going to talk about how the research that was done for this book identified key attributes of high-performing software development teams. And the book is totally focused on high-performing means you are producing a better outcome for your business. It's more profitable, it's got a bigger market share, it's more productive. And there are 24 key characteristics. I want to talk about the 2 that are related to architecture. And the first one is loosely coupled architectures. People tend to think microservices, but there are other ways of loosely coupling your architecture. But if you can produce an architecture where you can make a change in one place, test it and deploy it independently without having to coordinate with someone else, you are more likely to be able to do that quickly and to get good feedback, and you have better business outcomes. To do that, you have to have a cross-functional team because you need everything in one team to produce the outcome you want. You need your testers, your DBAs, the ability to set up infrastructure all in one team. And you need empowered teams. So the team has to have the ability to make decisions about how they're going to solve a problem, including the technology. And Accelerate calls out that tool choice is part of that. It is effective to allow developers to choose the tools that they use. And together I call these things autonomy. So autonomy is an important aspect for being successful in producing business value. But there's a bit of a problem for me, particularly as someone who was in charge of operations at the Financial Times for quite a long time, which is there's a trade-off between autonomy and standardization. So they're both things that have value, and we can, certainly at the FT, when we started to think about autonomy, we maybe reduced the view of how valuable standardization was. So autonomy has the advantage that you can release code on demand, which means you get a quick feedback cycle. When I first worked at the FT, I would write code, it might go live 6 weeks later. I couldn't remember what I was trying to achieve. And if I needed to work out why it had gone wrong, I had to go back quite a long way, perhaps, and in the code to find out what had happened. You can choose the optimal tools. So let's say that you want to have information about the systems that you have in an organization. That doesn't make sense to put in a relational database. One team owns many systems. A graph database is the best solution, but if you only have one way that you can do something, you end up shoving that into a relational database. And you have happier teams. And this book, Drive by Dan Pink, talks about what motivates people, and it's autonomy. So can you decide what you want to do and how you're going to do it? Mastery, which is can you improve your skills and learn? And purpose, which is do you actually value the direction that you're going in? So autonomy is important as part of that. But standardization has benefits. If you have only got one way of doing something, it's much less complex to understand it. If something goes wrong, you've got a really good chance of knowing how to identify the problem. You have a lower risk. If you have 12 different technologies, each one of those could have a security vulnerability. You have lower cost. You don't have to buy licenses for multiple things. You might get a vendor discount for bulk. And it's easier to move between teams. So if you're someone who is on one team, it's good for a company to move developers between teams. It's good for the person. But if you're a Node developer and the other team does Java, it's much more difficult. So I worked at the Financial Times for 11 years. I started as a Java developer building a content API, and I left as a technical director for engineering enablement. And so I want to talk about how I think you manage that trade-off between autonomy and standardization. But I'm going to start, well, so I'm going to start by spoiling it and saying I think the answer is paving the road. You want to build a route to production that is good for most people and have a mechanism for them going off the road if they need to. But I want to explain how that is the thing, how I got to the position of thinking that's the right way of doing it. And so I'm going to do a little bit of history. How do we get to the paved road? Then I will talk about the principles we agreed at the FT about what we put on that paved road. And finally, what we defined as the process for going off-road. So our path to the paved road. When I joined the FT in 2011, we had a very monolithic architecture. And we had a mandatory platform. Everything was written in Java. It was deployed to Tomcat. It had Apache in front of it, and we used a relational database. And that was the way that you worked. If I kind of think of a pendulum, with everything is mandatory at one end, and it's a free-for-all on the other. We were right over on that right-hand side. You didn't really have the ability to say, this isn't the right tool for me. And an example of the kind of thing that happened was we had an incredibly complicated, completely configurable build and deployment tool that required people to sign off in various steps. So what actually happened was every dev team had a box under a desk somewhere that ran Jenkins, because you got quick feedback from Jenkins. You didn't get quick feedback from this other thing. And the way we were structured, we had an infrastructure team. We had our own data centers. They would buy servers. They would rack them up. They'd set everything up. We had development teams, and we had an ops team. And when you did a release, you would package it up, give it to ops. They would do that deployment. And that's slow. There's a lot of handovers involved in that process. And the detail here doesn't matter. This was the process for getting a release out in 2012, I think. Monolithic systems, not automated, can't do a zero downtime release, so we have to find a time to do a release when there's no news happening, which generally, thank God, the FT is a business newspaper, so it's a Saturday, but it would probably be one Saturday a month, and it could take hours. And that kind of is just incredibly painful. You're always waiting for someone to do something. And if I try and think about where that sits on an autonomy standardization graph, there's a lot of standardization. As a developer, I understood how to solve the problems, what I needed to do. And I spent the majority of my time writing code and then waiting for that code to get to a point where I could validate that it was okay. So not much autonomy, lots of standardization. And we wanted to make the pain go away. So 3 things happened at once. The first thing was the infrastructure team built a thing that was imaginatively called FT Platform. It had an earlier iteration called FT Cloud, but basically it was a platform for FT developers. So this was about, can we provision servers and set up build and deployment pipelines automatically? And they had great success with this. So when I joined in 2011, it really did take 6 months to get a server to put the new content API on. By 2014, it was minutes. So it's a huge improvement in your ability to get code out, and it's completely automated. So you have a sense that then this server, you're going to know what's on the server. You could rebuild it, and it will still be absolutely exactly what you expect. And this change, where you could, as a developer, provision a VM, and then it would come with automatic shipping of logs to a log aggregation system. You could do monitoring, and it came with a build and deployment pipeline, meant we could do the second change, which was to adopt microservices. We could never have done it until we could provision like this. And microservices are loosely coupled, and that meant that we could actually do zero downtime deployments, which meant that this is a graph from late last year of how many releases we did. It's an average of about 100 a day. It's something like 250 times as often as the releases we were doing with the previous approach. And that means you get quick feedback. Quick feedback, and you can iterate, and you can actually do experiments. There's a lot of value in that. We adopted a DevOps approach alongside microservices. I don't know if you can be successful if you don't, because if you're releasing it as a team 10 times a day, you can't hand that over to someone else to operate. You've got to be responsible for deploying and operating that code. So we had people who were doing DevOps, and this is what our structure looked like. And these are this is not my DevOps team full of DevOps engineers. This is a DevOps team where there are developers building and operating their software and a platform underneath it. So this was quite an improvement, but there were some problems. On the standardization, a little bit less standardization, because you could provision your own machines and you did a lot of the deployment yourself. You could choose, for example, to install a document store rather than using the relational database. You had a good reduction in standardization where you could use better tools for the job, and you had a little bit more autonomy. But lots of decisions were made for you with FT Platform. It was very much a system that was built by infrastructure engineers. So they abstracted a lot of the complexity of AWS away, which is great until you actually want to do something that they didn't assume you would ever want to do, like use a managed database. I was a developer. I could provision a VM, but the infrastructure team had not given me permission to deploy code. So I could provision 10,000 VMs, but I had to get an infrastructure engineer to run a script to allow me to then put code on them, because they were still not quite convinced that it was safe to give developers access to production. And it was all or nothing. The assumption was, this is great, you're going to use it. So if you wanted to do something slightly different, you wanted to innovate in some part of that deployment and build pipeline, you couldn't really use FT Platform. And what happened, actually, is that teams completely chose other options. They thought, well, this is really constraining us. My team had started to build microservices. They were really small, and we were deploying them one per VM because that's what the platform permitted. So we adopted containers, but we couldn't do that on FT Platform. So now we've got our own platform. Another team chose to use Heroku because they wanted to use managed databases. They wanted to give someone else the problem of a lot of what they were running. And so what we actually ended up with was a minimal platform. The teams had opted to effectively take the minimal amount of stuff in common and build their own platforms. So swinging right over to the other side of the pendulum. So there's now every team has a platform team, because the Heroku team have to have their own platform that they run, and the containers team have to have their own platform. So there's this kind of thinner platform underneath it all of things like DNS or maybe log aggregation, observability tooling that you could reuse. But all of those teams now have somebody that's spending a lot of time on infrastructure and operations. So you can get a change out much more quickly, but of your 6 developers, 2 of them are doing stuff that is not focused on business value. So FT Platform, minimal platform, loads of autonomy, not much standardization at all. And this is just a small subset of the things that we had at this point. So within the FT, you could deploy on EC2 or Lambdas on AWS. You could deploy to Heroku. There were people using GCP. We had people writing Java, Go, Node, Python. We did have some stuff in Scala. I'm pretty sure we had other things as well. And lots of different databases. And some of this is good. Some of it's good to have different options. But if you have all of this, it's hard to sort of support it all and understand it all. Too much autonomy means too much risk, because you're relying on all of these technologies to be managed by someone who is going to fix a problem, is going to identify a problem, who will know that there's a security issue. And I don't think the average developer on a team is checking to see whether there's a vulnerability in whatever it is that they've adopted. And there are high-level goals that you have as an organization. So the FT does not want to be in the news for being hacked because there's some problem with the developer stack. If you have autonomy as a developer to spin up a server, you might go, I'm going to make it nice and big just to make sure I don't have any problems with it. But if everyone does that across the whole organization, suddenly you have quite a big AWS bill. And when there's an incident, I want to understand what's going wrong as the head of operations. I don't want to discover that you chose to put your logs somewhere else because that was easier for you, and suddenly I don't have a view across the entire estate of what was actually happening. So to try and mitigate some of this, we introduced some guardrails. So the idea with the guardrails was that they would define the things we expected every team to do. So if you are going to go and build your own platform on Heroku, these are things we want you to do. And we tried not to make this too restrictive. These are important things. Like, we'd like you to log every change and release that you do, so that when something goes wrong, we know if new code just went out. We'd like you to consider accessibility, and all of these checklist items were backed up with information. What does it mean? What does this policy mean, and how can I comply with it? So it's not talking about how you do development. We expected development teams to know what to do in terms of writing code, testing, deploying. This was the stuff that you may not have expertise in the team. Guardrails bring you a little bit further back towards standardization, because we're basically saying you can go off and choose your own tech, but you have to do certain things that help us as an organization. We also formed a new group at the bottom called Engineering Enablement. And it may look like I've just renamed platform to Engineering Enablement, but it involved a big mindset change as well. So rather than thinking we're going to build a platform, we're going to build it and then just give it to the developers and they can use it. And I ran this group. We wanted to work with the development teams to build the things that mattered to them and partner with them. And this is the other book that probably has been mentioned multiple times already at this conference, Team Topologies. It talks about optimizing teams for fast flow. And the stream-aligned teams that are mentioned here, that's those teams that are doing product engineering. They're aligned to a stream of value. They're all about business value. The engineering enablement group was made up of platform and enabling teams. And those are teams that are building a platform that allows those development teams to make fast progress and providing specialist knowledge to them. So engineering enablement had common platforms and services, expertise in things like observability, incident management, security, and they provided insight to the teams. So we could show you how you were doing on some of these quality things around guardrails. We made a lot of investment into showing people where they needed to take action. And these are the kinds of things that were owned by that engineering enablement group. So you could come and have a look at these topics and find out what was there and available to support you as a group. And so the guardrails probably reduced autonomy a bit, and it gave us a bit of standardization. But it's not enough, that whole ability to choose anything. There's a real problem when you have to move a service from one place to another. And honestly, you never get the boundaries right when you're first working on something. So let's say that you realize, actually, this functionality is much better as part of this group, this domain. It's very hard to do that transition when the application's written in Node and deployed to Heroku, but the team that's receiving it runs Go containers on EKS. That's unnecessarily difficult. You can't move people because there's a lot of stuff invested in the languages and the frameworks that you use. If you're a Node developer, you probably don't want to move to a team that does Java. You've invested something in that identity. And full stack stops somewhere. So if you've got a team of, say, 5 or 6 developers, they can't have expertise in all of the areas that matter. They can't know security and accessibility and the infrastructure and everything else. So the FT has the idea of T-shaped engineers, where you have depth in some area and are able to move into the areas on either side. But there's somewhere where that stops. And if you've got this setup with teams that have their own platform and an engineering enablement team, the engineering enablement team really struggles to help in some areas. If you've got multiple languages, they need to write a library for every one of those languages, and they need to understand every one of those languages. That's difficult. If you've got 5 different ways of hosting stuff or 6 different continuous integration pipelines, the value of that engineering enablement team is going to be less, because it will take them far longer to be able to build things that actually help people. But autonomy is important. People need to be able to choose the right things for what they need to achieve. So you have to find a way to give enough autonomy, which is the paved road. So paving the road is about building a path to production that gives people everything they need. It takes care of things for them. So you could walk along that path on the left, but when there's tarmac down, you can make quicker progress. You're less likely to turn your ankle in a rabbit hole. It's safer and it's quicker. Paved road should be fully supported. So if you're on the paved road, you don't have to patch things when there are security incidents. There's nothing that you have to do that isn't focused on that business value. So you use our deployment pipeline, you deploy to AWS using this, we'll support it for you, and it'll be done for the long term. But crucially, it's not mandatory. And there are a couple of reasons for not making it mandatory. The first thing is innovation is important. Innovation and that sense of autonomy, but you want to make it possible for teams to say, I think there's this new technology that is going to be really good for our business case. And they should be able to do that. Maybe they've got a thing that they need to achieve that you don't have in your paved road yet. And what tends to happen to start with is you go, no, we will do that for you. We'll build it for you next quarter. Oh, sorry, it won't be next quarter, it'll be the quarter after. Well, that's just holding up people. So you need to basically say, it's okay for you to go and solve your own problem or try a different approach. There's a really good blog post from an ex-colleague of mine at the FT, Matt Chapman. It's 6 years old now, but it's a really interesting post about how internal teams should think of themselves as service providers now. So if you're a service provider, you're competing with all the other service providers. So this development team doesn't need to use the thing that you built. They can use something else. But you should be able to build something that absolutely meets their needs because they're your customer, they're your only customer, they're right there for you to talk to. And so having that idea that the paved road isn't mandatory, it makes you as a team building these services properly listen to what your customers need. And not build what you think they need, or at least you can build what you think they need, but then you need to sell it to them. And teams can go off-road. If they go off-road, it's going to be harder going. They've not got the paved road. They're going to be going through the undergrowth. They have to be the ones that patch the stuff that they've got. Probably means that they'll be on call for it. It'll take them longer. They won't be spending as much time on the interesting business value stuff. So generally, the hope is that teams will only go off-road when there's something really valuable in it for them. The first thing that you need to do when you are going to take this approach is you need to understand what you actually do have in your estate. So we invested in a central system in a graph database that was a graph of our information. So we would know what systems we had, which teams owned them, the people that were involved with the teams. And this was quite extendable, and that's actually really useful as well. But I wouldn't build something like this now. I think they exist. They didn't exist in 2015 when we started doing it. But if I was looking to buy something, there are a couple of things I definitely want. This was super useful for ownership, and ownership every system needed to be owned, and we said every system has to be owned by a team. And it's surprisingly common for someone to say, no, it's fine, this one person understands this system, but that person's working on another team, or they might leave the company. If you don't have a team that owns a system, you don't really have ownership. So clear ownership by a team. Unique codes for each system. Our BizOps system generated a unique system code. It was so useful because you could use it, for example, to tag AWS resources. You could put it in your logs. It connected so many things together, and then you can start to navigate that graph to ask and answer interesting questions like, here is this log, which team owns this? Here is this resource. Which team is that? Can we get the costs of this team in AWS resources? You can do that because of the graph. And we added a lot of other stuff into this over time. So GitHub teams, repositories, things like health checks that checked and monitored these services. We also added records of incidents, DNS zones. And you just end up being able to understand your estate. And that's really important if there is autonomy and people have gone off and chosen something else, to still be able to find the person who can help you, the team that can help you fix a problem. And we used that graph to provide, for example, a dashboard for every team, and that was generated from the information. And this is quite useful as a forcing function, because if people said, we don't own that, we could say, well, if you fix it in the underlying data, you won't see it on your dashboard. So that pushed people to update the information. So Paved Road moves us further towards standardization, but in a way that allows space for autonomy. And so you get a bit of a benefit of both. And there's a great article from Charity Majors all about the golden path, which is the equivalent of the paved road, why you need it, how you go about doing it. And I recommend reading that. I want to talk a bit about the principles for building the paved road, because you can't do everything. Like in any team, you never have the resources, and you especially never have the resources in an internal team, because every time there's a decision about which developer does what, you're fighting to keep some developers doing this thing that for product is not that exciting. So you've got to choose. So how do you choose what you're going to build? Well, we spent a bit of time thinking about principles, because if you can produce some principles, it makes every decision that you make easier, because you can say, does it comply with our principles about the things that we build? And I'll talk about them now. I think they're kind of the FTs. There's some of them I've changed from what my experience is. The first thing is about building what people need. So it's really easy to think you know what people need. Rule of thumb for me would be, if you can't get another team to commit to work with you on it, don't build it, because they don't really need it. Even if they filled out a survey and said, we really want this thing, if they won't commit time, you could build it and they'll never use it. So make sure that you're solving a problem that people have, and a problem that they couldn't buy somewhere else. So generally, every development team will tell you that they don't like the way they track work, but you don't want to be trying to build an alternative to Jira. It's just like, find something else. It's a concept of a desire path. Desire path is where you find a path like this. This is where people want to walk across this park. It's not paved, but it's the way they want to go. If you can spot the desire paths that have already been created in your organization, that's a great way of identifying stuff people really want. So, and also you have to you combat the not invented here thing. If you see that a team has solved a problem, as a central team, you can adopt that solution and you can make it available to everybody. You already have at least one team that's incredibly enthusiastic about it. You know it works, and you can take that and make it something better. So desire paths are a good way of identifying this. Where you're doing any of this, you need to show people, if you want people to migrate to it, you need to give them something that is better than whatever they've got and tell them why it's better. So we created a new change API a few years ago, and we did that in response to people. So the change API, you could just call it to log, I'm about to release this change into production. We found out people were removing it from their build pipelines because it wrote to Salesforce at the back end, and if there was any problem, that would fail, and it would fail the build. So people just took it out of the build pipeline. So when we built the new one, we said it's far more resilient. And if you want to add it to your build pipeline, we've created a Circle CI orb. So anyone building Circle CI, this is all you need to do. And then we sent someone to sit with a team to add it to all of their systems. And then the first time someone in an incident was able to show that something had gone wrong just after a change, because we had a Slack channel that it wrote all changes into, suddenly everyone wanted to use it. So we'd shown that there was a need, it gave value, everybody moved to it. If you're doing this kind of a job, you're doing internal DevRel. Like, you are selling what you do, and you probably want to attract engineers into your team that understand that and want to go out and sell it. The second thing we had to do at the FT was when everyone moved away from FT Platform, the team building it just went, fine, you're on your own. So anyone who was already on FT Platform, it was that thing about, I love this thing, I'm using it, it's gone, and there was no plan for where you went. So we said, we have to reduce the risk for people of adopting this. So we need to make sure that it is owned and supported. So owned is, if you start using this, there is a named team that you can go and ask for help and questions of. There'll be a Slack channel you can go to. There will be an email address. It will be owned. And supported meant It's maintained, it's fixed if it breaks out of hours, if it's critical, and we have a plan for the long term. So it's going to be around for years. We will guarantee you that it's going to be around for years. And if we replace it, we will produce a migration path and we'll give you a significant amount of warning that that's going to happen. Because otherwise people will just go, I'm safer using something that you haven't built. Particularly if there's been a breakdown of trust in the past. You have to prove that you are trustworthy in building these kinds of tools. You don't want people to have to wait. And some of this is like you don't want people to wait for you to build a thing, but also it's important that people, when they have a need, that they can just get on with it. So first aspect of this is engineers has a task they want to do. Can they discover that there's a thing that they can use for this? Is it easy for them to know that someone has solved this problem? So we had these tech topics. We had this single place that was an entry point into all documentation about all these kinds of services. And when I took over engineering enablement, every team had found their own documentation solution. So to find out about a particular problem and whether there was a solution, you had to know what team might have built the solution and where they kept their documentation. Is it in a wiki? Is it in Google Docs? So they're all in one place, and you can go there and you can find it. And one of my colleagues created some O'Reilly posters and put them up all around the office and in Slack. This is where you go for information. We wanted people to be saying, go to Tech Hub, go to Tech Hub, that's where you find your stuff. Documented. So, documentation is important. And you want there to be step-by-step guides for people so that if they have a thing that they want to do, they can do it. You don't have to solve everything, but 80% of the stuff people want to do with a particular tool is common. And then for the 20% where someone has a special need, they can reach you, that you're discoverable and you can help them. But most of the time, they'll just get on with it without you won't even know that they're doing it. And so our documentation had a kind of common structure. So what is it? How do I get access? Anything else that I need to know? Where is there more information? And it's as far as possible, we wanted to make things self-service. And that's so it doesn't hold anyone up, but also it just stops you as a team from having to constantly approve something or give someone access with a key. Make it self-service. If you're worried about what they might do with it, provide stuff in your tooling that stops them from checking an API key into production, whatever. Just provide that guardrail within it. DNS changes was an example here. So long time ago, we made it possible for people to make DNS changes through commits to a central repository. And people really liked that. But when the team went back and said, any feedback, there was a sense that, it takes hours sometimes or days for this to be approved. And the team went and looked at hundreds, and there's a really good blog post on this. They went and looked at the last 150 DNS changes, and they categorized them, and they found that 80%, there was no comment or discussion on the PR, it just got approved. So they looked at patterns of things that they could just approve automatically because it was never a problem. You're deleting an entire entry, fine. You're adding an entire entry, fine. If it's got something that needs someone from CyberSec to look at it, automatically send that to the CyberSec team. So it really sped up that self-service. And this was this is their analysis. You hit the approve button, get the robot to do it. You need to make things easy to use, and some of that is about the documentation, but easy to get started. Think about what the first thing is that someone's going to want to do with this. Make it so they don't have to wait for you to give them approval. You just can do a task, but also consistent experience. Because what you don't want is that someone has used multiple ones of your tools, but this one is completely different, or uses the same name for something, but it means something else. So try and be consistent in what you're trying to do. The next thing was really about allowing for autonomy and innovation. So sometimes people will use the tools you build in ways that you didn't expect. And if you build that tool so that it is possible to do that, you get all kinds of innovation. So it's the Unix philosophy of lots of things that you can compose together, independent, composable tools. On the paved road, they all fit together, but if you want to use just some part of it, you can. So we had serverless blueprints. People often use the serverless framework to do Lambda work at the FT. There were lots of blueprints for simple things that you might want to do. You want to read an item from DynamoDB. You can just copy this blueprint and drop it into your code base, and you've got that working. An example of people using tools in ways we didn't expect. The Change API. The team that do DNS started logging all the DNS changes into the Change API. I don't think I'd even considered that would be a change that we'd do, but that meant you could see every DNS change when it went live. That's really useful when there's a problem. The web team decided to start logging when a feature flag value changed. So if you're releasing code and deploying code separately from when you turn on feature flag on, actually, the thing that's important is when did the feature flag change? Because that's the point where you might see changes that are affected by that code. They didn't have to come and we didn't have to have any work with them. They just started writing changes into the API with a feature flag tag, and that was that. So you get innovation through being open to change and building things that can be used. So automation friendly is good. So APIs, CLIs, SDKs, just things that people can stick into their own code and automate in some way. The next thing that was important is to think about helping people to do the right thing. And there's a couple of aspects here. So the guardrails are nice. I expect that most developers at the FT had not read the guardrails. They'd certainly not read the whole lot of them. They might read them when they need them. So let's just make it so you don't have to read them, because the things that you're trying to do will help you to get it right with the guardrails. So we have this central system called BizOps. We want every record to be in BizOps. There's a guardrail that says must be in BizOps to go to production. You can't create an AWS resource that isn't tagged with a system code. It's got to be unique system code. You have to get that system code by going into BizOps. I mean, you could try and make up a system code, but actually we check. So you can't tag it with a system code that doesn't exist. That you don't need to understand the need there, but it'll drive you to do the things that we care about. Runbooks. We want runbooks that anyone could use to try and fix a problem with a service. And that could be someone that didn't build the service, but it could be you in 6 months' time. You don't remember necessarily some of the decisions that you made. So we had certain fields that were important to us to be filled in a runbook. And this is maybe 5 years ago, most of our runbooks did not have a lot of information in. So we basically created something that would look through all the fields and create a score. It's a score based on different fields are more important than some of the others. You can say, oh, this particular system scores 91 on the runbooks. And then we aggregated that together so you could see for a whole group of developers how good their runbooks were. So we could say, well, the community team is doing really well. This was amazing. The guys that managed, and they were guys, the guys that managed our print production systems went from 0 runbooks to 99% of their runbooks because they really were motivated by the competition of that. And people would send messages. So in Slack, I got a message just saying, hey, Sarah, we've overtaken you. And my team, the operations and reliability team at the time, of course, we were very competitive. And I've taken out the next Slack shop where we basically overtook them again. So that stuff works. It works. You want things to be safe to use. So sensible defaults, small blast radius, protect people from making mistakes. It shouldn't be possible to do it so badly that you bring down another service or that you incur a huge cost. It shouldn't be possible. You want to make sure that if you're using the paved road, security issues are fixed for you. All of the policies that the FT have should be just complied with, and you can feel safe and reliable with the right level of availability, scalability, performance. Right level doesn't mean massive amounts of all of this. It depends on your system. And the way the FT did it was we just had a simple thing where there are 4 types of service: platinum, gold, silver, and bronze. And honestly, mostly things were either platinum or bronze, because bronze meant no out-of-hours support, doesn't have to be multi-region. Platinum meant someone needs to be supporting this out of hours and it should be multi-region. And there are a few other aspects to it, but that was the major thing. So you could build things and know that it would be platinum. You could say it's got to be platinum standard, it's got to be bronze standard. Going off-road. So you need to define how to go off-road. So it's absolutely fine to do it, but there's got to be some process. So you can do it if the capability doesn't exist. So what you want to do doesn't exist. And that includes even when the team's saying, yeah, we're going to do that soon. It's like, no, if the capability doesn't exist, you can go off-road, but you do have to tell us what you're going to do. Must comply with the guardrails. You must do whatever you're doing. It isn't I'm just going to put this thing in production without any of that monitoring and log aggregation because we're really important solving a business problem. No, that is a problem. You can try it out, but as soon as it's something you're relying on in production, it must comply with the guardrails. And you need a plan for the long term. So let's say that you have built this new thing that didn't exist. We're going to roll it into that platform on the paved road. Or you've found an alternative. You are using a different CDN because there are reasons you can't use the same CDN we've used before. At some point, we're going to have to make a decision. One of those CDNs is the one that we're all using. So either we take the work you've done, you've convinced us that this is the right one for us, and we move everyone onto that, which is what happened at the FT, or we basically go, no, you have to go back. There will be some cases where you run multiple things, but you should at least have a plan, because otherwise what happens is 3 years in, the developers that made the decision don't work on those teams anymore. They've left FT or they've moved on to some other team. And the people who are left doing it are like, I don't want to have to run a CDN. I don't want to have to do this thing that I did not sign up for. So you need a plan for the long term. So Log4Shell is a great example for us of the benefits of some of the stuff that we've done. So the FT is not really a Java shop, but we built microservices. Some of our microservices was built in Java. One of the nice things about microservices is you don't have to do big bang upgrades. So there were still some Java services running. The teams that ran them had never deployed a Java service or indeed written Java mostly. But we could find them because the information was all in our graph. We could find every GitHub repository that had Log4j. We could find those services and we were able to manage that process because of the information we had, the strong culture of ownership, and a central team that could basically just run it as an incident. And that worked really well. So wrapping up, I think paving the road helps you to balance giving people autonomy, but enough standardization that it's not incredibly painful for people to get things done. You don't grind to a halt. It means that those teams that are building products can focus on the most important work, which is about the business value. It is not ever important to be building a continuous integration pipeline made out of lambdas, which is something one team wants to do at the FT. I just don't think that's not the most important thing. And it's more interesting to be solving problems than it is to be getting deep into the infrastructure for something where you just don't really care about it. You just want to do this other thing. This is a great roundup about developer experience, because paving the road is one of those things in the developer experience area. You want your developers to be spending more time coding, less time thinking about and working on the infrastructure. And this focus on developer experience is not just about the organization, because why would a developer put up with a poor developer experience when they can go and get a job somewhere where they can do work without getting caught up in all of this, where they can find a good approach to doing all of this. So it's a retention thing as well. So these were my principles for building the paved road. So build what people need, support them long term, don't make them wait. Make things easy to use, allow people to extend and adapt them. You don't necessarily know the best way to use the things you built. Someone else might have a great idea. You should encourage that. You have to kind of sit back from that mentality of you control this. You're looking for innovation. You should be going, that is amazing. I was not expecting that. And help people to do the right thing by making it safe, secure, compliant, cost-effective, all of those aspects. And that is it from me. Just a reminder of all the ways to share your experience. And I think that we may not have time for questions. Thank you.